Members, welcome to our online class today. As we wait for the rest of the members, I would like to remind us that we shall stick by the online class rules, which include that you must at every given time.
Hello, sir.
Yes, please.
Can you kindly raise your voice?
All right. Do you hear me now?
Yes, yes.
Yes, I was actually addressing us and I was saying that we need to have our cameras turned off and also we need to mute. There's some echo from Kennedy Ogola.
Yes.
Can you mute your microphone? Yes, now all of us have acted very well. All our microphones are muted. We are waiting for one more person or two so that we may proceed. So before we proceed with today's lesson, who will remind us what we did previously? Or who will tell us more about what we learned previously concerning the semiconductor diodes? What are they? What are they used for? And for you to react, you will first raise your hand and I will allow you to proceed. Kennedy, can you give us a recap of what we learned previously?
I can try.
Yes, go ahead, Jacqueline.
Okay, we learned that a diode
Yes,
is an electronic device that
yes,
conducts current in one direction.
very correct, Jacqueline. A diode indeed is a device that connects in one direction. Caroline?
Okay, we also learned about PN diodes, the formation of PN diodes.
Yes. How are they formed?
I can try.
Yes, go ahead, Kennedy.
A PN diode is formed when an N-type and P-type extensions and conductors combine together,
Yes,
where there is a recombination that takes place and a mobile ion deposited between the P-type and N-type material forming depletion layer.
yeah, thank you for that contribution, Kennedy. Now all mute your microphones. And so today we shall be learning about something related to what we had done. Are you seeing my screen? What I have shared?
Yes,
Yes.
What is on the screen?
Rectification.
Correct. So today we are progressing from what we learned previously and we shall be dealing with rectification. And so rectification, under rectification, we shall cover the following. We shall define rectification. we shall state the methods of power rectification, and we shall describe the half-wave rectification process. And let me find out if we have ever interacted with rectification. Can someone tell us what rectification is? Unmute your microphone.
Okay, let me try.
Yes.
Rectification is the process of converting AC power to DC power.
Correct. Conversion of AC power to DC power. Does anyone else have a different view about the same? Yes. Okay, like Jacqueline has described or defined, it is the process of obtaining unidirectional currents and voltages from alternating currents and voltages. And it is true that the unidirectional current is what we call direct current, and the multidirectional current is the AC. Now, right away, we look at the methods of rectification, and they are actually three of them. We have half wave, we also have full wave center tapped, and we have full wave bridge. All of these are methods by which DC current power can be obtained from AC, alternating current power. And on the screen, I hope you're able to see uh, what I've shared. It is the process of half-wave rectification, and you realize that this rectification process has an input. We also have the transformer, which is usually a step-down transformer. Kennedy, can you unmute your microphone and tell us what a step-down transformer is? Kennedy.
Yes, step-down transformer is where we reduce the amount of power from the higher level to the lower level. For example, 240 to,
Can the rest mute the
for example,
microphones? Yes.
yes,
Yeah, proceed now. There was some echo from your side, but it's now fine. Yes, you're saying?
step down is where we reduce the amount of power from the higher level to the lower level.
Correct. Correct. Like Kennedy has explained, is that step down means you obtain a lower power from a power which is higher. For example, normally you have from 240 volts, step it down to maybe 24 volts or 12 volts. And now from there, are we all seeing what I'm describing on the screen? Can you mute your microphone and confirm to me that you're able to see it?
No, we are not able to see, sir.
All right, all right. That's good. Let me share again. How about now?
Invisible.
Are you seeing anything?
No.
No. You're able to see now, right?
Now we can see it.
All right. All right. Mute your microphone, Ogola. Correct. Now this is the process that takes place in half-wave rectification, whereby when the P side is positive, this side here is sufficiently positive with respect to Q to this side. This is actually describing the positive half cycle. Now what happens at this point is that current is able to flow because the diode is forward biased. So when current flows, you are able to see an output on the load. What happens when there's now the negative cycle? At this point, current is trying to flow in this direction, that is counterclockwise, and you find that it meets the diode being reverse biased. That means it's not able to flow. Now when that happens, there is no output here. So this is shown by this flat signal on the zero level. Now this cycle repeats itself. In the next positive cycle, and now that one is half-wave rectification. Now, as a summary for this lesson, we were able to look at rectification and methods of rectification, whereby we say we have this half wave, full wave, and then we are able to look at the half wave rectification process. The full wave center tapped and full wave bridge, we shall be able to look at them in our next and subsequent classes. Who has a question on what we've learned today?
I have a question.
Yes, go ahead.
On the half wave rectifier waveform,
Yes,
we have a portion of the waveform that is missing.
yes. From this diagram,
Can you tell us why it is missing?
all right.
Yes,
Okay, like I
the waveform.
it's all right. It's all right. Can you now mute so that we can proceed? Now, our girl has just asked, why is it the return of the waveform that is missing? And from what we said earlier, is that the waveform that we are able to see is the one during the positive half cycle, when current is flowing in the direction such that the diode is forward biased. And at that point, we are able to see this waveform, the one I'm cycling here, coincides with the positive cycle in this point. Now, at this point where there is no waveform, that means the negative cycle has been cut off, it has been truncated. The reason is because the diode at negative half cycle is reverse biased. So Kennedy, I hope your question is well addressed.
Correct.
All right, thank you. Any other question from class or any reaction? Okay, so thank you very much for your participation. I will send an assignment through your class email. I will ask that every member before the end of business on Friday next week. Thank you very much and have a lovely week ahead. You can now leave the class at your own pleasure. Thank you.